In this lesson, we're going to take a look at solving one type of exponential equation that really comes down to recognition. That's it. Okay, if you can recognize this situation when it's presented to you, this could be the easiest thing you've ever done. But if you don't recognize it and you don't think about numbers, if you're the kind of person who just blindly starts rearranging things and punching into calculators without any thought whatsoever, this is going to be challenging for you. And so the big key here is to think before you start. These just show up here and there. It's not like they happen all the time, but when they do happen, they can be very simple if you can see them coming. Okay, so what we have here is an equation. There's an equal sign there, and I've got an x on both sides. But notice the x is always in the exponent. It's in the power. Okay, now usually that means I'm going to have to deal with a logarithm at some point. But in this case, it's a special scenario where that's not necessary. This is something my mind can handle. What I have to recognize, and the reason these are called common base equations, is 4 and 8 have something in common. And I'm not talking about the fact that 4 goes into 8, okay, because that may or may not be true depending on which scenario you're looking at here. Let me say that again. It probably will be true, but it's not the feature we're looking for. Okay? What I want to notice is that 4 has a base. It could be written differently, and that same base could be used to write 8. Okay, and if you don't know what base I'm talking about here, I'm talking about a 2. 4 could be written as 2 squared. And 8 could be written as 2 cubed. Now, I still have to write the exponents. Okay, that doesn't go away. I still have to have those. So x plus 2 and x minus 5. And what I'm going to do at this point now is I'm going to use my knowledge of exponent properties to multiply those together. And in this case, I'm going to have to distribute because there's more than one term up here in the exponent. So this is 2 to the 2x plus 4 equals, let's do the same thing over here, 2 to the 3x minus 15. Now, if you get this to happen, and you are somehow able to get the same base on each exponent without changing what it means, that's key, then basically you can kind of ignore these. Okay, they don't really cancel out, but what we're trying to find is what makes this exponent equal to this exponent, because the base is already equal. So I'm going to rewrite it now just using the exponents. Okay, let's go up here where I have some room. 2x plus 4 equals 3x minus 15. And right now we have basically a linear equation to solve to get that variable by itself. This is something most of you do without even thinking now. It's just a habit. Okay, I'm probably going to subtract 4, and that gives me 2x equals 3x minus 19. And then I'm going to subtract 3x back over to this side, and I'm going to get negative 1x equals negative 19. So I divide by negative 1, and I get x equals 19. Now, how do I know if that's correct? Well, I can always go back to my original equation, and if I need to, I can use a calculator, and I can say 4 to the 19 plus 2, which, by the way, some of these numbers are going to get really big once this works out, equals 8 to the 19 minus 5, and I just want to know, is that equal? So I calculate this, and I see if I get the same gigantic number. And if I do, I did this correct. So that's what we call a common base equation. If you did not recognize that these two numbers had the same base that they could be written with, then this is probably going to be a challenge for you. There are other ways to approach it, but this is obviously the quickest and easiest one. So the key is, can you see these scenarios coming? Is there some way to make the bases the same without changing what they mean? Just rewriting it a different way.